Hello guys, in this video we are going to learn how to interface ADC0804 with 8051 microcontroller. Unlike other microcontrollers like PIC, AVR and Arduino, 8051 does not have a built-in ADC. Hence to use any sensor with 8051 we have to use an external ADC. In this project we will be using ADC0804 to interface with 8051 microcontroller. So before starting with the circuit diagram, we shall see some features about ADC0804. Well, it has 8-bit resolution, differential analog voltage inputs, 0 to 5 input voltage range, no zero adjustment, built-in clock generator, voltage at V reference by 2, that is pin number 9, can be externally adjusted. Now let's talk about the pins of ADC0804. So it has 20 pins in total. The CS pin, that is the chip select pin, is used to activate the ADC0804. Then the read pin, which is RD pin, is an input pin and is active low. This pin helps the data out of the ADC. Then the pin WR, that is write pin, is an active low pin which is used to initiate the ADC to start the conversion process. Now the pin clock in. Clock in is an input pin connected to an external clock. Then INTR, that is interrupt pin, it goes low when the conversion is over. Then the pins V in, plus and minus, these are the pins, analog pins connected to ADC and ground respectively. Then A ground is connected to ground. Then VREF by 2 or the reference voltage pin, this pin, the 9th pin, is used to set the reference voltage and by default it is 5 volts. The pin D ground, this is the D ground pin or the digital ground, you can say, it is connected to ground. Then the pins DB0 to DB7, these are the output data pins for binary data. Then the VCC pin is connected to power supply. Then the clock R pin, the clock R pin, this pin is for resetting the clock. So this was all about the pin description of ADC0804. Now we shall discuss the circuit diagram and its connections. So this is the circuit diagram. So in this project I have used AT89C51 microcontroller, a crystal oscillator of 11.0592 MHz, 2 capacitors of 33 microfarad, 1 capacitor of 10 microfarad, then 2 capacitors of 10k ohms. 2 capacitors I have used for 10k ohms. Then a push button for resetting the microcontroller. 8 resistors of 330 ohms are connected to LEDs at port 0 to limit the current. The data pins DB0 to DB7 of ADC are connected to port 3. The RD pin, the read pin, that is this pin, these pins, RD pin, WR pin, then INTR pin are connected to port 1 through their respective pins. And then A ground, this is the A ground, then D ground and V in pin, these 3 are grounded. Then the V in plus pin, this pin is given the input analog voltage by varying the pot. This is the pot. The clock is provided by connecting 10k ohm resistor and 150 picofarad to clock in and clock R to clock in and clock R pins. Then the LEDs, you can see the LEDs. The LEDs are connected to see the digital output which will be obtained from ADC0804. So this was all about circuit diagram and its connections. So we shall now see the code. This is the code. So firstly, including the header file reg51.h, then defining the port P3 as input, then defining the port 0 as output, as I said, we will be able to see the ADC output in these LEDs, that is in this port only. Defining the read pin now as P1.0 it is connected to, then write pin is connected to P1.1, then interrupt pin is connected to P1.2. So WR, RD, INTR, these are the three pins we have defined. These are the three variables, sorry. Define the delay function now. This is the delay function, and it will be used for producing delays. Then define the ADC function that does the actual conversion part, which is the main part. So then coming to the main part, this is the main part where the input port is made high and the output port is made low. So in the while loop, the conversion part is done with the help of ADC function. So in ADC function, the read pin is made high to read the analog voltage, which is at pin V in plus. We will be reading the input like given to the analog, the analog voltage whatever is given here to the V in plus, it will be read by this pin, RD pin. So then the WR pin, which is the right pin, it is made high after giving some delay. It is made high after giving some delay. It actually initiates the conversion process of ADC. So now the moment the conversion gets over, the interrupt pin, that's INTR pin, is made low, otherwise it will be high. Now once the interrupt is low, the read pin stops reading the input. So the data after conversion is in the form of digital, which is in data pins, that is input port, that is P3, right? So this data is passed on to the LEDs whose port named as output, that is P0. So it will be passed to the LEDs. So that's how the conversion gets completed through ADC. So that's all about the coding. Now we shall create the hex file by building the target first. So the hex file has been created now and it is named as adc.hex. I will import the hex file now to 8051 adc.hex, then open, OK. Starting the simulation now. Yes, you can see for this analog voltage whatever is here, the digital output is shown in the LEDs. Now if I change the input analog voltage, the output is also changed. I will change it, and so the digital outputs are shown. So it is different for different analog voltage. So that's how we do the ADC interfacing. That's how we convert analog to digital voltage with using ADC0804. This voltage, the output voltage can be different if resolution is different. Like it is 8-bit, so it is showing this output. If it is some other resolution, then it might change, the output might change. So this is it, this is the project, that's it. Thank you guys, thank you for watching.